Good afternoon, everyone, and thanks for joining us in this Tech TOC session today, which is about green profit. My name is Guillermo Masot. I'm a managing partner at Alfium. It's an infrastructure consultancy and supply chain management. We provide advisory services within M&A, operations consulting, and supply chain tech. And we're also involved heavily in the research in the topic that we're in today, which is about financial operational impacts of decarbonization in the ports industry. I'm very pleased to be here after some time and seeing, again, customers, friends, and colleagues. So I hope you enjoy the session. I'll make a very short introductory note before I introduce you to the panel. What is green profit, in my opinion? Green profit is about conducting or undertaking operations in the ports industry profitably in the era of the low carbon economy. And in my view, there are three factors or elements that are going to impact the process or the transition towards decarbonization in the next 10 years. The first one is obvious, is a huge regulatory stream coming to us in our industry. So we have various precedents. We had the IMO 2020, which resulted in most of the top carriers moving on into installation of scrubbers in a staged way. We have another way of regulations coming in IMO 2023, which is even more stringent. It's about potentially impacting the supply side of container shipping, very strict carbon intensity thresholds. We also have here in Europe a very ambitious program called Fit for 55. You probably heard of it. Which may or may not, is subject to discussion, but may involve the introduction of carbon taxes into our industry. For sure it will happen into shipping, yet to be seen it happening into the CTO segment. But there are certainly requirements, for example, like onshore shipping, onshore power, provision of onshore power, or new LNG or new fuel terminals introduction in ports becomes compulsory at TNT ports. We're hearing in another session in this TOC conference from the European Union representative who will be speaking about this package. Aside the regulations, we also have a very important element to consider in terms of decarbonization, which is the access to capital and investors. When working on transactions, we see that the ESG components of M&A is becoming a more heavy or a heavier work stream. And it used to be typically very important in transactions involving multilateral organizations or public banks, the EIB, IFC, etc. But now we're seeing also the private financiers giving a lot of importance to this, to the point that a poor ESG rating can even restrict your access to finance or even including aborting a transaction. And finally, and not least, is societal expectations. I think everybody here in this room and the society as a whole, we're placing more importance on aspects of sustainability. And I think we're coming to a point where society as a whole is going to reward corporate citizens that actually perform well in terms of sustainability, and on the other hand may end up punishing commercially those participants that are not up to the expectations. All these three elements, regulations, access to capital, financial implications, and societal expectations, have large implications for container terminal operators in terms of increasing operating expenses, additional investments in green equipment or infrastructure, generation of potentially new business models and sources of funding, for example, from OSP or carbon credits for good performance, environmentally speaking. And so this is the context around the green profit. In order to elaborate more of this, we have a very exciting lineup of speakers today, which is going to give, including senior representatives from the container terminal operating industry, port equipment and suppliers, port equipment. And having said that, I'm going to introduce our first speaker, who is Sahar Rashid Beji, who is the head of decarbonization of APM terminals. She's leading the program of the company towards transition towards net zero by 2040. She holds an MBA from Harvard Business School and holds previous senior advisory experience at McKinsey, where she co-led the McKinsey Sustainability Insights, where she was also a co-founder. Thank you very much. I hope you enjoyed the session.
All right. Thank you very much, Guillermo. I don't have any slides for you, and I'll try to keep my speak very short to give time to my co-panelists as well. And I think what I'm going to actually talk about probably lays out the foundation of what's really at stake when we talk about container terminal decarbonization. So hopefully that's a good introductory talk for your speak. So I want to tell you about what is it that we are doing at terminals. So what are our targets and commitments at APM terminals as part of the broader Maersk? I want to tell you about how we are aiming to deliver on those targets. And then I want to open up a little bit about the challenges that we are facing, which I think is probably good food for thought for this audience, where I expect a lot of problem solvers and solution providers be. So first and foremost, what we are doing, you still hear me if I stand with a little bit of distance from the, good. We are targeting, like our parent company, Maersk, net zero by 2040, and 70% reduction of scope 1 and 2 emissions by 2030 versus a 2020 baseline. I think this audience all know what scope 1, 2, and 3 is, but just in case, what we're talking about when we say scope 1 and 2 emissions, scope 1 refers to emissions associated with burning of fuel, so predominantly diesel from diesel run equipment in our terminals, and scope 2 are emissions associated with the emissivity or emissions of the electricity that we procure. So that's the target for 2030. We're very proud of it. We are deliberately taking a leading position within the industry, and it's not some lofty ambition. We're pretty serious about it. These are going to be structural reductions, so no offsets. By 2030, we're not targeting buying any offsets to deliver on those targets. So what does that mean then? And before I get into what we're doing to get to that target, let me also clarify a little bit on what we mean by net zero by 2040, because then by 2040, we're not just talking about those scope 1 and 2 going all the way to zero. There will be some scope 3 emissions, which are emissions of our upstream or downstream, so our customers or our suppliers, which we partly also see ourselves responsible for. How much scope 3 in what areas still to be seen, but I'm going to talk a little bit about what actions we're taking on that front as well. So how are we getting there? First and foremost, and I think this is a topic that is within the context of decarbonization generally often overlooked, is energy efficiency and energy optimization. In a lot of industries and a lot of corporates that in my consulting career I've worked with, you walk in and you can easily find 10 to 20% energy reduction opportunities. So actually, with our good friends at Siemens, we're taking a holistic approach, going terminal by terminal, doing detailed audits to actually find energy, and this goes both to fuel and electricity, but definitely no regret move on the electricity side, so on, let's say, transformer or reefer optimization, to see how much energy we can actually save, which directly would translate into emission reductions. So that's the first step. We're taking it very serious, and we're literally going terminal by terminal, looking at A to Z of all the levers that are applicable, and definitely taking action on the ones that are, quick payback time, things as simple as switching to LED lighting. The beauty of energy optimization and energy efficiency is also it's amongst the decarb levers that's actually has a business case. That's actually MPV positive, and we're going to get to the more difficult ones in a bit. The second one, which is the harder one, and I'm going to be talking about that a little bit more, is electrification. And, well, broadly speaking, you can say it's about switching from diesel to another fuel pathway. And of course, there you can think about hydrogen, methanol, ammonia, you name it. But because we want to move fast and we want to move now and we're replacing assets as we speak, we actually don't see, unfortunately, the other pathways available to us, or at least not commercially making sense when you look at total cost of ownership comparing, for instance, a fuel cell terminal tractor with an electric terminal tractor. So while we monitor it closely, the path for us for now in the coming decade is, broadly speaking, direct electrification of our assets. And this actually means a major capex allocation in the coming decade. And we're talking about just in the next decade, the north of 1,000 terminal tractors, hundreds of straddle carriers, hundreds of empty container handlers. So these are large volumes that we're talking about. So reduction of scope 1 and 2 is not complete until you actually make sure that the electricity that you're procuring, and increasingly so as you electrify equipment, is green. And that we're also doing by making sure that we procure green electricity, we put the rooftop solar, we buy PPAs, we buy VPPAs, so anything that verifiably counts as green electricity. You may think about biofuel, renewable fuels. We're also looking at that. We do look at it opportunistically and as a transitional lever, but not as a measure that can structurally take us there all the way to net zero, especially because, as we hit the end of the decade, probably most of those volumes are going to flow to the industries that actually don't have any other way of decarbonizing. So those are the three main areas that we are decarbonizing our operations with. But as I mentioned, scope 3 is in scope as well. So shore power, auto mooring, any way we can help our shipping customers reduce their scope 1 when they're on our turf is in scope. And increasingly so, also carbon embedded in the products and services that we supply. So this is something that's work in progress, but I'm sure a lot of those of you who are our suppliers are going to hear about it sooner than later on what our requirements are or what we are looking for when, as far as emissions are concerned, when we engage with suppliers. So that's the gist of it. Scope 1, 2, 3. Now, what are the challenges that we face? First and foremost, when we talk about electrification, availability of the technology. So we're not exactly shipping. We don't need quite a technological breakthrough for electrification. And you may hear that the electrified or the hydrogen version of almost all equipment that we use are available, but are they? So that's, with for instance, challenge we're facing with straddle carriers or some of the other equipment. And sometimes it's also as basic as just having grid access. There are certain geographies where we can't actually electrify purely because there isn't a stable grid access to electricity. And how can we go all the way structurally to net zero while those mobile harbor cranes are not actually, we can't put it on the grid. So that's one. And when technologies are available, and I'm going to, obviously there are a lot of challenges, but I'm going to use a technology lens here, and of course you talked about cost. The next challenge is when technologies are available, there is still a huge productivity and performance gap. Just by the virtue of the fact that the machine needs to go out of operation to be charged for 15 minutes, an hour, hours, that means that when you switch a diesel terminal tractor, you probably need 1.2 to 1.3 electric terminal tractors. And then just extrapolate this into the whole fleet being electrified. Do we even have enough space in a terminal? for a considerably larger fleet size. And I'm not going to even get there whether the local utility is able to actually procure all the electricity that we need. So there is a productivity gap. There's a performance gap. The products that are available are often moving slower, or the performance either on moving or moving up and down is not quite there. So there definitely is a performance gap as well. And finally, most importantly, there's a massive cost gap. And of course, we are doing our part in being the first mover and committing volumes and showing volumes, but we really need our suppliers to also take a step towards us and help us in actually closing the massive cost gap that exists today. With that, I'm going to wrap up, and Guillermo, the floor is yours.
Thank you very much, Sahar, for these interesting views about the APMT's roadmap towards decarbonizing and all the comprehensive views. So I'd like to introduce our second speaker, who is Troy Collard. Okay, Troy is sales manager, general manager of sales within PepsiCo over the last 7 years. He also had held sales and executive roles in Mitsui, subsidiary companies in US, in Japan, since the late 90s. And also, today he's been heavily involved in the implementation of decarbonization solutions in the ports of Long Beach and Los Angeles. And he's going to just give us his view of his experience directly on site on the matter. Thank you, Troy, and we look forward to hearing from you.
Thank you for the introduction, and it's a pleasure to be here today to talk about the Port of LA and the Port of Long Beach and the project that we're doing right now. To follow on Sahar's comments, to this point, if you're looking at zero emissions, you're looking at electrification. That's really what's available today. And then the other thing that she had mentioned is about there's a cost gap, and she'd like to see suppliers somehow work towards getting helping out terminals such as APMT in terms of getting to zero emission or decarbonization. So this is going to be for Port of LA, Port of Long Beach. I'm actually out of San Francisco, so I deal very heavily with this. The Port of LA and the Port of Long Beach is the largest in the U.S. About 40% of the cargo coming into the U.S. is from the Port of LA, Port of Long Beach, with 7 large terminals. And we've been working with the port on working on hydrogen. Hydrogen, the key word that you hear a lot about. But the problem is that the demand and the supply is neither are there. If you don't have demand in terms of equipment that's hydrogen powered equipment, you don't have the supply of hydrogen that's right there at the port that then could fuel the equipment. And so what we did was we collaborated with several other Japanese companies and to put together a project where we can fill that entire scope of supply and demand. So is this? So the Port of LA, the Port of Long Beach, right next to each other. When we're looking at hydrogen, what we found is that there are 3 equipment that RTGs, top handlers, and UTRs that we think are going to be applicable to hydrogen. Not everything's going to be applicable to hydrogen. So some equipment, hybrids, electric hybrids, battery, they're fine. We're only looking at the larger pieces of equipment that require more power to operate. And but a couple of the challenges, again, the supply and the demand's not there. Cost of hydrogen and the cost for the installation. So what we did is we have a grant from the Japanese government. We call it NEDO, short for the New Energy and Industrial Technology Development Organization. And not only are we involved in it, but other manufacturers of equipment is involved in this project. We've already started on this project, but it's in the initial phases. So to introduce the collaborative partners, we have Toyota Tsusho, which is more of the trading arm of Toyota. You're familiar with Toyota. They're very, very advanced for fuel cells and fuel cell technology. So in this role, Toyota Tsusho would be responsible for the hydrogen production, the hydrogen refueler that would go into the terminal, and then for the yard tractors inside of the terminal. Hino Motors will be responsible for a hydrogen drayage truck, and then PESICO and Mitsui E&S are responsible for developing a hydrogen fuel cell RTG. So the idea behind this project is that we want to produce locally meaning LA Long Beach area, and then consume locally in all of the terminals in the Port of LA, the Port of Long Beach. So I don't know how familiar you are with California, but Central California has a lot of dairy farms, a lot of ranches, and they produce a lot of methane gas. So the idea is pumping that methane gas, piping it down to the Port of LA, Port of Long Beach area, and using that as the energy source for producing hydrogen. Then from that local production source, we would then truck the hydrogen into the terminal to fuel the top handler, the RTG, yard trucks, and drayage trucks. So this is a feasibility project that we are now moving forward on. So that's for the overall project. And for PESICO and for Mitsui, we're really just involved in the RTG. So just to give you a bit of an idea about the RTG, we have several models of RTGs. But as you know, we don't have hydrogen there today. But terminals may need equipment today. So the idea is, can we get some sort of a bridge technology that then we can easily convert over to a zero emission source? And so that's when we developed our near zero emission. That's actually in production right now. And this is, we've already dropped the engine size down, so it is very low emissions in comparison to a conventional RTG or something. So even today, you get your reduction. But this project requires zero emission. And so that's what we will be doing in the future. So again, these are just some annual numbers for how much in carbon dioxide that we can save. Now, certainly, the hydrogen that will be produced is going to be blue hydrogen. It will not be green hydrogen. However, because it is methane gas, and that methane gas is being used, so it's not going to be, methane gas is worse for the environment, and this will produce some CO2. It will offset, but I'm still saying that it is blue hydrogen, not green hydrogen that would be from renewable sources. So this is being our NZE RTG. So this is already being produced, and as you can see, we have just the small diesel genset. The idea is that you can use that today, and with an eye in the future of changing to zero emission. If we look at the overall schedule of this project, as of today, we are already done with the fuel cell design. We're already procuring the fuel cell, and we're ready to be doing testing at the end of this year. And once that testing is complete, then we're going to be fabricating a new zero-emission fuel cell RTG to be run at the Port of Los Angeles. And that piece of equipment will be there in 2024. So we are less than 2 years away from having that first machine at the terminal. So there is a gap, certainly, versus electrification, but the gap is not years and years away. It's only a couple of years. So this is what we'll be doing. This is the hydrogen fuel cell. We'll be doing the integration ourselves at our subsidiary company. And again, we'll be putting it onto our, so this is the picture of what we already have. This is the hydrogen tanks. And the radiator, we'll be finishing up with the fuel cell here at the end of this month. To go on to our test RTG that's in the Oita factory. Again, because this is a conventional RTG, we will need to add on the battery packs. We'll need to add on remove the diesel genset and then put on our fuel cell for the initial tests. So, in summary, I just want to explain that we looked at this project as how can we, as Japanese companies using Japanese funds, move forward with a zero-emission hydrogen possibility at the Port of Los Angeles and the Port of Long Beach. And something that we can do, maybe not today, but in 2024, actually have a working demonstration. This demonstration for the grant requires 4 years of data collection, but that doesn't mean that 4 years of data collection is required before that can be put into use. That's more for just the NETO requirements. And our goals for this, and every terminal is going to be different, but for us, our success criteria is that we run 2 back-to-back shifts without refueling. And then, because that's in Port of LA, that's very common. Other terminals in Europe or maybe a different situation that would be easily adjusted with the amount of tanks. And that operationally, it's exactly the same. We went this approach more than electrification just because you avoid the CapEx requirements that it has to be paid upfront, which takes away from the profit. And it also allows for the terminals to continue to procure RTGs or yard tractors or top handlers as they do now, and then modify over to a zero-emission solution over time, which then spans out that CapEx and avoids that initial cost, and at the same time continues to have flexibility in the yard, the same that you do today. So that's a summary of what we're doing in the U.S., and we're looking now for opportunities for doing similar things in other parts of the U.S. We're part of the Japan Hydrogen Forum, and we're meeting with, this is also sponsored by the Japanese government, and we're looking at Houston and other places where they're looking at putting in hydrogen hubs. So we believe this is a viable option, is hydrogen, not just other zero-emission sources. Thank you. Time.
Thanks very much, Troy. I think it was very encouraging to see the progress made in terms of hydrogen and all the supply chain around that coming from methane. I find it very innovative. And I'd like to introduce now our next speaker, is Christopher Saavedra. Christopher is manager at Calmar, where he, sorry, I have my chuleta in Spanish, my notes, sorry. Christopher is a professional in the area of container terminal automation. He's got 10 years of experience in ports operation of management, has direct industry experience. He started as a military naval officer, and then in the management on conventional automated terminal operations in Latin America, where he was very involved in the implementation and testing of new technologies. as I said, he has held various positions at containers terminals. In his last position, he led the improvement and optimization of processes, connecting operational processes with personal, IT, and customs. At the moment, he's going to show us Kalmar experience around the CO2 roadmaps towards decarbonization. Thank you. Hope you enjoyed.
Well, great to see you all here again after 2 years, and I'm really excited to share with you all the lessons learned I have been identifying together with the customer. So the topic for today is the CO2 reduction roadmap, and how can you enable not only operational, but also environmental and financial, because those three are totally aligned. If you're missing one, probably you need to go back to the blackboard. So the agenda for today is that I will be explaining a little bit more about the megatrends we are currently facing out there. How can Kalmar can support you starting this CO2 reduction roadmap, and I can share a little case example from an extract we recently did to a customer. So probably you are currently facing one or maybe four of these megatrends out there. Mega vessels, okay, really cool, you can serve the mega vessel, but how about storing the cargo? How about the resources needed for those? And how are you planning to actually load those cargoes that are going to be, shipped via train or maybe via truck? Again, sustainability, the topic for today. And yes, Sahar mentioned a really interesting topic here about the struts, Troy about the RTG, but there is a lot of things behind. The equipment is only one piece of the whole puzzle. How about the infrastructure? How about the grid? How about the capabilities you need to enable those type of equipment? Then we got industry consolidation, so basically alliances between the shipping lines, and as you may know, digitalization and automation in our industry. But then what is driving eco-efficiency here? As you may see, there is more and more public and internal pressure to become greener. It sounds easy, but it's totally a journey, and it's something you cannot just go to your neighbor and copy-paste. You really need to understand your way of working here. So there is a lot of legislations coming, investors need to become greener, and finally, there is a lot of customer interested to buy a green service. This is a really nice graph over here, and basically operators can focus on the red bar of the graphic here. So on that 24% that they can actually control. And there are many ways you can actually, or there are many actions you can do to implement these days to reduce the CO2 emissions. And it all depends of your mid, short, or maybe longer terms over here. But there are a lot of technologies, a lot of fleet management applications you can use here, and many other actions. But, well, then how can you respond to these needs over here? So I would like to share 5 practical steps, and I will be happy to understand a little bit more about your specific case. But basically, these steps can be implemented quite and right away here. So the first and most critical one is the analysis of the current operation. You need data, a lot of data here, quality data. And you need to make the proper analysis, assessments over here of how are you currently working. You need to understand if you can actually make a retrofit of an equipment. You need to make the proper assessment of that equipment. But then on top to that, what is the current operational cost to operate those type of equipment? Does it make sense still to retrofit those? And well, all the risks and opportunities you can face in your terminal. Then the second step, and personally that's one of my favorite ones, basically we support the customer here presenting different operational scenarios that will enable not only operational but also financial and environmental targets. So if you are really willing to go green, there are different options. You can go into hybrid solutions or even full electric, but at the end, it all depends on your specific case. Because just as my colleagues over here at the panel mentioned, yes, you can go full electric, but then how are you going to handle those peak of electricities if the main grid is not able to handle those? So all these need to be considered over here and need to put into the table. A critical aspect here is that the people's and skills also are critical to consider at this stage. How all these teams will be handling this new type of equipment and maintaining this type of equipment. Then we reach the third step, the financial impact, well known as the business case. And I may say this is one of the most interesting one. Actually, here we will sit with the customer, evaluate what is the CapEx, OpEx, and I need to make a little dot here that especially when you jump into full electric solutions, you need to take a look not only at the CapEx from an equipment point of view, but also on the infrastructure needed. And normally that's a big game changer, so to say. Then how about the ROI and all the grants and government funding? So what we have seen over here is that according to the region, it's not the same to be supporting the customer in the US or maybe Latin America or Europe or Asia. It's totally different. So you really need to take a look into the current legislations. What is the CO2 taxation if the country is already paying a CO2 taxation? So all these need to be considered at this stage. Then finally, once we already got free, so to say, the previous step, then we can go into an implementation phase over here. And again, the reality is that greenfield sites are quite few worldwide. Most of the cases are brownfield terminals with an ongoing operation, trying to become greener on an ongoing craziness. So they need to find a way, and you really, you cannot come just like and shoot down a piece of the terminal. There is no way. So you need to find the best way to implement this, and it should be a step-by-step approach. And finally, this is always, as I told you, a journey. So there is a lot of continuous improvement over here. So basically, there is a lot of training, not only for the technician team, but also to the drivers. If we are talking about an automated terminal, there is a lot of training behind to the guys handling exceptions. That's quite critical. And especially maintaining this electrical power fleet, it's totally different compared to a conventional one. And again, there are a lot of outsourcing possibilities over here. This is a really high-level overview. And there was a customer with an existing setup with a 55 diesel straddle carrier fleet. On top of that, they got 24 hybrid straddle carriers. To make the exercise we established here, 4,000 operating hours yearly. So based on those numbers, we established an initial carbon emission, as you can see over here. But basically, the target for the customer was like, hey, Kalmar, we're trying to reduce the CO2 footprint. So what will be the options available? So we presented different scenarios that we built together with them from an equipment point of view. You need to be aware that obviously if you change the amount of operational hours, it will be proportional again to all these scenario 1 or 2. But again, as you may see, scenario 1 got a 21% reduction over here, mainly replacing the diesel strut with hybrid struts. And scenario number 2, we also shifted some diesels to hybrid, but also we increased the amount of fast charge machines. But again, when we start putting together all the CapEx, OpEx, pros, cons, operational evaluation, environmental, and financial, the customer decided to go to scenario number 1. And the main aspect here was that there was like a major investment from a infrastructure point of view to handle a full electric fleet. And I was talking with Checker, for example, okay, how about having like a storage capacity for your terminal? So there are a lot of things we can figure out. But again, there is a CapEx behind those. And the tricky part here is that, yes, it looks quite simple, but again, you need to match the financial investment plan of the terminal together with a reduction roadmap you're planning here. So that's quite tricky. You cannot just get rid of the current fleet because there is still some lifetime on those equipments. So the summary, how to get started. I really love this one and understand your way of working. That's critical. There is no copy-paste from your neighbor over here. Set the operational, environmental, and financial target. Make sure data is collected and shared among the team. You need to do the proper analysis for your specific site. There is always a way to find different opportunities to go into a step-by-step approach. And well, my team and my colleagues are most happy to help you on your specific case.
Thank you, Chris, for the very insightful presentation about how Kalmar strategizes the approach towards asset management. And finally, our last speaker today is Shekhar Kubal. Shekhar Kubal is going to speak about the power of the power conversion as part of the decarbonization puzzle that we've been speaking about here today. Shekhar is working at Danfoss, he's global head of marine and electrification in the company. He's got 28 years of experience, coming mainly from ABB in India. And he also held global roles with Vacon, which then became Danfoss in Finland back in 2014. He's been living in Finland since 2001, and he's had several global roles in product management, sales, marketing, etc. He has a degree in physics and is a postgraduate degree in power electronics, and he's very genuine interest in contributing towards all activities towards better sustainable world. At the present time, Shekhar is working with his team in building the strategy towards power conversion and other applications in the fields of decarbonization. Shekhar, all yours.
Hello, everyone. Good afternoon. Thanks for coming here to listen, and thanks, Guillermo, for good words in the introduction. So no introduction needed. I'm thinking, how do I start? I say I have a daughter, and she's 13 years old. And I'm sure, like me, many of you, you are also thinking about how to ensure that the environment is healthy around our children, not just for us, but also for our children. And today, if I look around, since morning also, it's not anymore a question, why are we talking about decarbonization? It's clear. It's understood by everybody, businesses, governments, administration, but also you and me, individuals. Our children are also learning that. In these mega trends, we are trying to solve the crisis of climate change, right? There was a discussion about technology. Sahar was raising this point. I would like to say that technology is there. Of course, deployment and the speed is the discussion. She also talked about that. So it's not a question whether technology will be taking us there or not. It's more about, will we be fast enough to do what we want to achieve? And what we want to achieve is not just a target, it's a purpose. Electrification, I think all the speakers today more or less stamping on this, that electrification is not the only one, but one of the major mitigation to solve the climate crisis. Let me say a few words about Danfoss, the business, the company through which I am contributing my 5 cents towards decarbonization, taking part into the energy transition. Here are my colleagues also here. They are also equally passionate about electrification. Just to give simple idea about the size or the glimpse of the company, around 37,000 people, 95 plus factories, and 7.5 billion euros of turnover in 2021. Like Sahar said about APM terminals, Danfoss has also took a leadership and setting a target about our carbon neutrality of our locations by 2030. And already some of those locations by this year will be declared carbon neutral as we speak. So there are several 100+ projects, small ones, taking place across the organization. We are mainly working through 3 business areas, starting from power solutions. They are coming from offering products and solutions for mobile machinery coming from hydraulics, but also this one is moving towards hybrid and electric. You have a good example here, VDL, where there is a AGV for demonstration. You can see the Editron machine as well as converter technology there. Then the climate solutions business, it's all about energy efficient buildings and offering products and solutions for that. And not only talking about our individual houses, but all the way to the district level, data centers. And Danfoss Drives business, where I come from, and both of my colleagues here, they come from, we have been saving energy back since 1968. The electrification world was not existing by that time. And now in this electrification journey, our electrification portfolio in Danfoss Drives, mainly we offer power converters. We are able to take different roles in electrification applications. We are here talking about green profit. It starts from energy source, where energy is generated. Then it is carried where it is to be used. So it includes the transmission and distribution. And then finally, the use of energy for doing some work. And it's important to talk also about saving while using the energy. Because in Danfoss, we say that the greenest energy is the one that we don't use, we save. Sahar was raising also the point about energy efficiency, and I think that is the low-hanging fruit in front of us at this moment. So we are going to talk about, and I'm going to show some glimpses of real examples which could be the candidates for green profit. Why? Why? Because these are existing, they are running, they are in operation, investments are already done, and they have proven their value, that they have a business case, they have done their return on investment, and as well, they are commercially viable. There is no doubt about it. I will be fast considering the time, but I think the main message is you will see the real life examples. Let's start with cranes, whether we talk about the cranes in the port area or also on the vessels. Here I can say that we can also talk about different types of cranes, whether we talk about RTGs, whether we talk about ship-to-shore cranes, straddle carriers, AGVs. Electrification is, at this moment, key element. Just by changing from hydraulics, there are still few cranes which are hydraulics. We have just seen few. Just by moving from hydraulics to electric, you are able to gain efficiency more than 50%. MacGregor cranes is one good example. They have shown this. They are using Danfoss liquid-cooled power converter technology. On the top of that, we have been also talking about introducing energy storage, doing peak shaving of the load, and that way you are able to reduce lots of fuel. That means directly affecting the emissions, but also downsizing the size of the engine, what you need, and that way reducing the wear. I think there are good examples around us. If we talk about ports and logistics, there are good examples just nearby. Maritime, we cannot leave out the vessels in the waters. They have a high impact on emissions as well. Here we see some examples, and we are going to see quickly. They are all around the port. They contribute also quite a lot of emissions with the traditional technologies. but quite much of them are either already fully electric or hybrid, depending on their tasks. You take examples of ferries, tugboats, fishing workboats, you will find them there. These are all operational. Here is from Denmark. Out of 15, the first one going fully electric and showing its value by saving 96% of the fuel. This one is quite near where we are in Amsterdam. It's a public transport, carrying people, mopeds, bicycles, working 24 hours, 365 days. But it's quite challenging. 4 minutes of journey crossing the IJ River and 2 minutes stop. And that's why it's hybrid. It's also battery there, so it is capable of running also on battery, but it needs to be hybrid because the stopping time is very short. This one in Norwegian fjords. If you look at the background, it's part of UNESCO National Park. Fully electric, that means no emissions, and also using Danfoss liquid-cooled technology, quiet, silent. It's perfect fit for its background. People enjoy it when now there is no more noise and no more emissions, and you enjoy the nature. This one is a tugboat. It's a workhorse. So it cannot be fully electric. However, important is it's hybrid. It's while transiting fully electric, but then when it is doing the actual work, it's hybrid. 20% of savings. These are charged at the shore, also stopping short time, so the charging power is quite high in megawatts, so few hundreds of kilowatts to megawatts. And by influencing this electric power on the shore, adding more and more renewable, you are able to influence eventually on the carbon emissions. This one is again in Norway. Sometimes the power is high, so it's supported by energy storage, so there is a real-life example. And the energy storage helps to reduce the stress on the grid, but also sometimes manage the economy by charging when the energy price is low. Again, in Norwegian fjords, so not just on the vessel, but also for charging, Danfoss power converter technology is used. Then going further, the bigger vessels, they are mainly hybrid with different applications, hybrid propulsion, addition of energy storage, as I mentioned, and more hydrogen fuel cells technology is being demonstrated as well. So I agree with Sahar that it's not yet like going with flow, but it's being tested. It doesn't need to be only new vessels. The existing vessels can be retrofitted as well. And here is a proof of that. Not to forget thousands of AC drives saving energy for the hotel load, like those cruise vessels. These big vessels, they need shore power, and that's also part of the regulation. The 10T core ports need to be equipped with the shore supply by 2030. That's happening. So here are these two examples. Time is short, so I will go quick. Last but not least, what's happening as a demonstration about green hydrogen was Troy was talking. So imagine the hydrogen production near the port, and when the vessels are running with direct hydrogen fuel cells or alternative e-fuels made by hydrogen, then this makes a lot of sense, saving energy. We are able to supply power converters for hydrogen electrolyzers. Not to forget the energy efficiency of the buildings using the AC drives. So in all these areas, the power conversion has been a common and key element. The technologies can change, but we can say that the power conversion will be there. We offer this portfolio of power converters for energy efficiency AC drives, but also AC to DC, DC converters, power converters for electrification applications. Service plays a very key role in these applications because high investment, long life cycle, very critical applications. And not to forget, these kind of electric machines are also on display there. I would like to end with one example. All these examples, we have been supplying power converters to our integrators, to equipment manufacturers, to EPC contractors. So it's always a collaboration. One cannot do it alone. Sharing is also very important. One example from close of all of our hearts, running between Vasa in Finland to Umeå in Sweden, ferry, carrying people and vehicles, able to run on battery when maneuvering near the population. But it's not just the point to talk about Danfoss having 35 megawatts of power converters installed there. It's more than that. Global and local companies coming together to make this happen. And not only that, the government, the city of Vasa and city of Umeå, taking active role in making this happen. So I think it also depends on collaboration and how we work together if we want to think about accelerating the energy transition. So I would like to end here, thanking you all, and let's drive the future stronger together. Thank you very much.
Thank you, Shekhar. I think we have some time for a few Q&A questions, quick session. So if you, please, the panelists can join me in the... So can I ask the public if somebody has questions? Otherwise, I have mine, I have the backup, just to break the ice. So let me just ask very kindly the panel. I mean, we heard very interesting insights from your different perspectives from the industry, or the operation, and also from the equipment suppliers and technology suppliers. I mean, in this regulatory environment, do you think there is a final ultimate bullet that will solve the equation towards decarbonization, or the solution will comprise a portfolio of technologies, electrification, biodiesels, hydrogen, power conversion? What's your view about that?
So I think that it's going to be a multiple of technologies that's going to be the key. It's not going to be one main technology that is going to run it. So for example, even today, you have electricity, you also have diesel, you already have a diversified set of energy sources. And I think that that's what's going to happen in the future as well. If you have complete electrification and the electricity's gone, then your whole terminal is shut down. But if you have multiple sources, then you can avoid that. So, and I do think that as technology improves, that costs will go down for each of these, just like any other technology. Solar was the same way, where it started out very high, and now it's very cost-effective for solar. So I think it will be multiple.
Answering the same question. So look, broadly speaking, there is no one silver bullet, right? So we absolutely need to fire on all fronts. But I think when we talk about a specific industry, and if you focus on terminal operators and the sort of equipment that we operate, I think it boils down to cost and availability of technology, right? And it's looking at it, and then there are a little bit of differences by geography as well, but at the moment, we're looking at cost and availability, and electrification is by far the most commercially and technologically viable option to go all in, right? But that very same solution runs into challenges in certain geographies where it's either the grid is not available or the heavy-duty equipment are actually super unproductive, or the productivity gap is so large. And it just happens to be in geographies where we actually think there will be a regulatory support for hydrogen production as well. And if then they're there, if you look at it based on availability and cost, all of a sudden hydrogen fuel cell makes sense. So I think in that sense we are very rational, and in absence of widespread carbon price and regulation, at the moment we really on a large scale we see electrification the way to go unless anything changes.
I'd like to hear from Chris too, from Kalmar's perspective on the point.
So basically, I love the word like silver bullet, I will reply like you did a color, a rainbow bullet here, because you really need to find which is the color that will fit your operational, financial, and environmental need. But well, from a Kalmar point of view, I may say, yes, we focus quite a lot in the electric solutions, but at the same time, we keep an eye. We do need to keep an eye to hydrogen, ammonia, or other sources these days, because we really don't know how things will change. But you also need to figure out that what is the technology available today. And yes, we bet a lot in electric solutions. That's my point here. And we really always try to explain, there is no one-size-fits-all solution here. That's my key message.
What about Shekhar?
Yeah, I can add to this that I think many of us have this feeling that there will be more than one technology, not just stay, but also needed. Because otherwise there will be huge burden on just one technology. Because at the end of the day, we are trying to find out, okay, from where we are digging this material, and then we are putting the pressure on that. Many a times also it speeds up when you are able to find more than one value into the use case we are using. Like you were saying, that it's very important to know for that particular area how you are operating and what are the surrounding resources. I can give example of hydrogen that, yes, you can use production of green hydrogen if you have renewables nearby, you have a good mix of renewable, then you can achieve green hydrogen. You can use it for multiple things, hydrogen fuel cells, e-fuels. But at the same time, you can recover the heat and use that heat for the heating if you have a need for heating. So finding more values makes the business case more stronger. That has been happening also for the batteries. And the last note I can say, at least my feeling is that batteries have lived that much of journey, they are going to stay.
Thank you. Unless is someone from the public want to ask something?
So what we see right now is the electric premium on the premium on electric equipment is super high as of now in 2022. What needs to happen in the future years that it goes down so that it is more feasible to buy those equipment for, let's say, customers like us?
Yeah, I may say that, yes, technology will be evolving, and that evolution will also make sure we can, reduce the pricing over here. But just as you mentioned, yes, if you compare like a diesel electric equipment versus a full electric, yes, it's more expensive, and I am quite open to that. But then you need to ask yourself, when you are building the business case, do I really need now the full electric equipment, or maybe the hybrid will reach my KPI I'm now looking for? So all those questions are the ones we need to ask right now. But yes, it's quite tricky. And if, for example, if a customer reach me out like, hey, Chris, I would like to become full electric now, I will really like to see the numbers, because we really need to make sure all the elements are in place. And you mentioned the equipment. Yes, that's one side. Probably the customer can handle the price of the electric equipment. But how about the whole infrastructure involved to handle that equipment? And that's a totally different story. So once you put all the pieces together, it's a big initial capex, just as you mentioned.
Just to follow up on that, if it still works, most of the equipment we buy lives for, let's say, 15, 20 years. And we are buying now. So it will stick with us till 2040 and more. And that's why we don't want to go out buy diesel or hybrid. And if we buy now the electric equipment, it will kill the business cases.
Yeah.
So that's the problem we need to solve as an industry, not just as a buyer or a supplier.
Yeah.
So the answer to your question, whether you need the electric equipment now, is yes, absolutely. We need it now, because the replacements are happening right now, and we're going to lock ourselves in for God knows how much emissions if we don't actually
do the switches right now.
Thank you. Any more questions? One more? Can I make one? And I make one question to the panel. The other backup question that I had is, I think as an industry and you as panelists, you've been very clear, have given very comprehensive insight about what your plans are for the future. But the important point of the grid capacity is coming again and again. Do you believe that the grid capacity in advanced markets like Europe, for example, would be ready to absorb that spike in megawatts associated to a whole electrification of our equipment fleets? And how big the gap is, and if there is a big gap, how heavy do you believe we need to lobby to the European Union, for example, to make it happen? That's my question.
If you are referring, Guillermo, about the grid infrastructure, that
the capacity of the grid.
Yeah, I think this is a really relevant question. Many times we are also thinking that there are many huge projects announced. Let's take example of recent is hydrogen electrolyzer projects in gigawatts. And then many times we are calculating, because you can call green hydrogen when you have a renewable energy. You have to use a renewable electricity to make the production. So are they really also happening? I mean, do we have renewable energy installed already? Out of that installed energy, how much is already in use and how much is really available for production? So I think these aspects need to go hand in hand. However, I also see that there is awareness about that when declaring these projects, because I have been also discussing with the people who are involved in this decision making. There is awareness about that. There are, of course, some kind of assumptions and estimations and I would say agreements as well. Not always they go hand in hand. We see that sometimes in newspapers. But this is a very relevant topic that it's so complex and activities need to be interconnected and interdependent, and that's coordination needs to take place. Sure.
Yeah, if I could add from the U.S. perspective, from California. So California is very aggressive for going for zero emissions. And for California, even for personal cars, from 2035, you can only buy an electric car or a zero emission car. So you can imagine there's 40 million people in California. So how much additional demand is going to be on the electric grid from 2035. So today may be fine, but 5 years from now, 10 years from now, is that still going to be the case? And at the same time, a lot of the electricity is being produced by hydroelectric dams. Well, California's in a drought. We need water. We don't have water in our dams now for even generating electricity. So there's other there's other factors that are involved in the amount of electricity, the capacity of electricity that you have at one time.
But addressing your question, and I think this goes specifically around Europe and beyond production and generation, there absolutely is a shortage of adequate transmission and distribution lines. And yes, we need to lobby for it, because the level of, I mean, here already in the Netherlands, there are outside the Randstad, basically, there are industries and businesses who are lining up for new connections, and they can't get it today. We're not talking about tomorrow or 5 years, 10 years from now. So there absolutely is a problem, because it's not only us, it's the whole industry that's being electrified, and it's demands that are doubling and tripling all of a sudden. And I don't think the grid is there, and there's something around lobbying, but also actually getting in line and securing your position. Yeah.
So I think that was the end of the session. Unfortunately, we don't have more time, but I invite you to speak with our panelists here and just to catch up with them in due course. It was very good to speak, to be here with you today, and I hope you enjoyed the rest of the conference. Thank you very much.